Hey guys, it's me. I'm here to talk about comparing and ordering fractions and decimals. So there are 5 steps to doing this. Step 1, change the fraction to a decimal by using division. Step 2, line up the decimals, then add some zeros as placeholders if you need to. Starting from the left, use place values to compare and then rewrite as the original number if there's no option to use a less than or greater than sign. If you have to rewrite them, then you'll need to use the original problem to do that. Here we are to compare using the less than, greater than, or equal to signs. So we have the decimal 0.65, or that's 65 hundredths, and we have the fraction 3/4. So what I have to do is I have to change the 3/4 to a decimal by using division, long division, because I've set up my problem and it's 3 divided by 4, so I write 3 on the inside of my long division bar and 4 on the outside. To do my division, I have to see how many times 4 goes into 3. 4 goes into 3 0 times. I write a 0 above the 3, add a decimal, bring my decimal up, and then I add a 0. Now I ask myself, how many times will 4 go into 30? 4 goes into 30 7 times. 7 times 4 is 28, and I subtract. I'm left with 2. I add a 0 and bring it down. 4 goes into 20 exactly 5 times. 4 times 5 is 20, so I subtract and I'm left with no remainder. So I have the number 0.75 and I wrote it directly below 0.65. And I lined up my decimals so that I can compare the place values. So if you look at which is bigger, 7 or 6, the 7 is bigger, so that means 3/4 is bigger or greater than 0.65. 3/4 is greater than 65 hundredths. We've got some examples here of comparing fractions and decimals. In this case, we're going to use our symbols less than, greater than, or equal to. So we've got 1/5 and 0.18, or that's called 18 hundredths. So I'm going to take the fraction 1/5 and use division. 5 cannot go into 1 0 times, and then I'm going to add a decimal here, bring it up, add a 0. 5 goes into 10 exactly 2 times, because 2 times 5 is 10. So which is bigger? I'm going to add a 0 as a placeholder. Which is bigger? My 1/5 is bigger. So I'm adding a greater than symbol. Same thing here. I'm going to divide 3 divided by 8. 8 cannot go into 3, so I'm going to add a decimal, bring it up, add a 0. 8 goes into 30, how many times? 3 times. 3 times 8 is 24. When I subtract, I have 6 left over. Bring that 0 down. 8 goes into 60, 7 times. 7 times 8 is 56. I subtract and I'm left with 4. Add a 0, bring it down. 8 goes into 40, 5 times exactly. So I'm left with 0.375. So I'm going to compare 0.45 and 0.375. Add a 0 here as a placeholder. Fix that. Now you just kind of compare according to the place value. If I'm looking in the tenths place, you'll notice that my 4 is bigger than the 3, so this number is greater. I've got, which is bigger, 1/10 or 1/9? Well, I can use long division to see if 1 can go in, or 9 can go into 1, and it cannot. So I have to add a 0 above the 1, add a decimal, add a 0. How many times can 9 go into 10? It goes in once. Oops, I forgot to bring my decimal up. That's very important. So 9 goes into 10 one time. I'm left with 1. Add a 0, bring it down. And you'll notice I'm starting to repeat myself. And I would continue to repeat that over and over and over again. So instead of writing a repeating decimal like 0.111111 forever. I can use the bar above the 1 to show that this is a repeating decimal, but I'm really comparing. So if we take a look, we have 1/10. 1/10 is written as 0.10, and then I have this repeating decimal 0.1111, and so I have to ask myself which in this case is bigger. And I'm looking at the 10th place of my decimal, and I notice that they're equal. So I have to move on to the 100th place. The 100th place of my decimal, you'll see that the 1 is greater than 0, and then that shows me that 1/9 is actually bigger than 1/10. I could have changed my 1/10 to a fraction, but it's harder to compare fraction to fraction than it is decimal to decimal. I might as well just convert any fraction I have to a decimal to be able to compare accurately. That's the easiest route. And then I have, in number 4, 2 745 thousandths, or 2 3/4. Like I said, I could try to change that to a fraction and compare, but it's harder because I would have to have equivalent denominators to do that. So I'm going to change the fraction to a decimal instead. So 2 3/4. Well, I know my whole number is going to be 2. Let's change my 3/4 to a decimal. That's 3 divided by 4. 4 cannot go into 3, so I have to add a decimal, bring it up, add a 0. 4 goes into 30 7 times. 7 times 4 is 28. I'm left with 2. Add a 0, bring it down, left with 20. 4 goes into 25 times exactly with no remainder. And then I have, so 2.75, and I need to put a 0 as a placeholder. So I've got the same whole number, the same number in the 10th place, and if I compare the 100th place, you'll see that 5 is greater than 4. So 2 3/4 is going to be greater than 2.745. You might have a situation where you need to put some fractions and decimals in order from least to greatest. Again, go ahead and convert all fractions to decimals so that you won't have to do too many more steps after that. So I've got 1/5, that's 1 divided by 5. 5 cannot go into 1, so I have to put a 0 above that 1, add a decimal, bring it up, add a 0. 5 goes into 10 exactly 2 times with nothing else left over. So 1/5 is equivalent to 0.2. Now what I'm going to do is I'm going to start stacking my decimals up based on their place value so that I can see how they relate to one another. So far, this one's smaller than that one. And now we're going to do 3/8. That's 3 divided by 8. 8 cannot go into 3, so I have to make it 30. Make sure you put your decimal up here and a 0 above the 3 representing that 8 cannot go into 3. That's so we don't get mixed up with our place value. 8 can go into 30 3 times. 3 times 8 is 24. I subtract, I get a 6. Add a 0, bring it down. 8 goes into 67 times. 7 times 8 is 56. I'm left with 4. I've got one more 0 to bring down, and 8 goes into 45 times. You can see here how important it is for you to know your multiplication facts, because to know your multiplication facts, you can easily do your long division. If it takes you a long time to recall your multiplication facts, then it's going to take you a long time to do division. And then the division means it's going to take a long time to put these in order. So all of those little things that you can do to help yourself, like memorizing multiplication facts, please do so, because it's going to make this whole process a lot easier for you. So my next number is 0.375. and then my last number is 0.28. I'm going to put zeros as placeholders. I'll put them in a different color so you can see that they're just placeholders. They don't change the value of my number at all, but I can use the placeholders to help me compare the decimals because I'm looking straight down and I've got my numbers lined up according to place value, tenths, hundredths, thousandths. Okay, so which one is the smallest? Because I'm going with the least, and it would actually be this one. So that's going to be my first one. So this, remember, was 1/5. Then if I look down, I've got 332, so this is going to be my next smallest. And then out of the two middle numbers, 3/10 is my next, and then this one's my last. When I rewrite them in order, I'm rewriting them as their original number. So the first number I'm going to write is actually not 2/10, but 1/5. And then the next number was this decimal here. Then the next number was this decimal here. And the last one, 3/8. So this is my answer of all my fractions and decimals put in order from smallest to largest. And lastly, you've got two problems. Compare this decimal with this fraction, and then put these numbers in order from least to greatest. Good luck.